Okay students, in today's video we'll be doing remaining questions of course code 0625. It's February March variant 2 year 2024. We'll start from question number 6. So figure 6.1 shows a full scale diagram of an object O and image I produced by a converging lens. The lens and its position on principal axis are not shown. Here we have an object, here we have an image. This is principal axis. On figure 6.1, draw a single ray to locate the position of center of the converging lens and a line to represent the position of the lens and label that L. So for a converging lens, a line that passes through center of the lens goes to the image and it is undeviated. You can see from this image as well. So I'm going to draw a ray from the tip of the object to the tip of the image, and wherever it crosses the principal axis is the center of our lens, and I'm drawing a line over here to represent that this point is my lens. Now what you're going to do after it, determine the focal length of the lens by drawing an other ray on figure 6.1. So how can we draw another ray? A line which is parallel to principal axis. When it reaches a converging lens, it deviates and passes through the focal point of the lens. So that means the line, wherever the line is cutting the principal axis, that is the focal point, and the distance between center of the lens and the focal point is focal length. So I'm measuring this distance, which is nearly 2.1. So my focal length is 2.1 centimeter. C part says the object is moved 2 centimeter closer to the lens. Now state two changes to the characteristics of the image. So let me just put the object 2 centimeter near to the lens. I'm just measuring it from the scale, and 2 centimeter nearer means that the object is here now. I am naming it O, and you can see now our object is between focal point and lens, or you can say center of lens. And for a converging lens, when object is between focal point and the lens, the image is not made by actual meeting of rays, but we extend our rays and they appear to meet at somewhere and make image. That means image is virtual, it is enlarged, and it is upright, and image is formed on the same side of the object. So I'm naming two different characteristics. Image is virtual and upright this time. Next question says draw a circuit symbol for potential divider. So potential divider symbols look like this. There is an arrow over the top of it. B part says figure 7.1 shows a circuit. Here we have a circuit of a potential divider whose input voltage is 6. There is one resistor of 1 kilo ohm and there is an other variable resistor, and we are going to receive our output voltage from here. Calculate the value of output voltage when the value of R is 3 kilo ohm. So variable resistor has value of 3 kilo ohm and you are going to calculate the output voltage. A potential divider will split or divide our total voltage into a certain ratio. In our case, the ratio is 1 and 3 because our resistors are 1 kilo ohm and 3 kilo ohm. So our total voltage is going to split in 1:3. So we can use simple ratio method to calculate our output voltage from resistor 1 kilo ohm. It will get one portion out of total 4 portions multiplied by total value of the voltage, which is 6. So the voltage across 1 kilo ohm would be 1.5 volts, and obviously the second resistor will get the remaining voltage, which would be 4.5. Now we will see an alternate method to do this, which is the formula. So let's suppose we have a potential divider whose input voltage is 6. Here is a resistor of 1 kilo ohm and here is a variable resistor of 3 kilo ohm. And we are supposed to get the voltage V1 across 1 kilo ohm. So that means we can use two formula. First is that we multiply the current flowing in the circuit by the resistor 1, or we can use the voltage formula, which is total voltage multiplied by R1 over R1 plus R2. I have written the formula over here. Let me substitute the values now because the total voltage is 6. So V is 6, R out is 1 over R is 3 kilo ohm, and again R out is 1. So again it's 6 multiplied by 1 over 4, which would be 1.5 volt again. Second part says that the value of R is adjusted until the current in the circuit is 1.7 milliamperes. Calculate the charge that flows through the circuit in 300 seconds. So we have provided the current, which is 1.7 milliamperes, or milli can be removed by 10 raised to power negative 3. And the time is 300 seconds, and we are supposed to get the charge. And you know that the charge would be equal to current multiplied by time. So current is 1.7 into 10 raised to power negative 3, and time is 300 seconds. So the charge to two significant figure would be 0.51 coulombs. Eighth question says, figure 8.1 shows a wire carrying a large current. So here we have a square card on which we have a wire and the current is flowing downward. One part says, figure 8.2 shows the square card viewed from above. So here we have a upside view of the same figure and the current is flowing into the page. And on figure 8.2, draw three magnetic field lines that indicate the direction of magnetic field and how the strength varies with distance from the wire. So to get the direction of magnetic field, you can use right hand grip rule. You have to grip your wire and make sure that your thumb is in direction of current. In our case, the current is downward, so our thumb should be downward. Make sure it's your right hand, and your curling fingers will tell you the direction of magnetic field. In this case, the direction of magnetic field is clockwise because our fingers are curling in a clockwise direction. If the current was moving upside, your thumb should be upside and the curling fingers are now anti-clockwise, and this is the direction of your magnetic field. Magnetic field is anti-clockwise. And now discussing the strength. Near the wire, the magnetic field is stronger and the field lines are closer. And when you move away from the wire, the magnetic field becomes weaker and the field lines move far apart. So I have drawn the pattern in a clockwise direction, and you can see that the strength is becoming weaker. So field lines are moving far apart when they are moving away from the wire. The current in the wire increases and the direction of the current is reversed. State how these changes will affect the magnetic field. So if you increase the current in the wire, the magnetic field will increase. And if you reverse the direction of the current, the magnetic field will reverse its direction, and now they will be anti-clockwise. So magnetic field becomes stronger and the direction of field become anti-clockwise. B part says electricity is transmitted at high voltage. Explain why high voltage increase the efficiency of transmission even with thinner wires. You know, thinner wires are supposed to have more resistance because their cross-sectional area is less. So when electricity is produced in powerhouse, the voltage of the electricity is increased, and when they reaches our home, using the transformer, their voltage is reduced again. So why we are increasing and decreasing the voltage? Because the power, current and voltage are connected by the formula P is equals to IV. If we increase the voltage, for same amount of power, the current must decrease. And you know, the power loss is measured by the formula I square multiplied by R. So if the current is reduced, that means power loss would be reduced. So thinner wire have more resistance, so power loss is more. To deal with this, voltage is increased to reduce the current for same power. According to power loss formula, P equals to I square times R. Reducing current reduce the power loss. Question number 9 says, an experiment directs alpha particles at a very thin sheet of gold foil. First part, Most of alpha particles pass through thin foil in a straight line. State the conclusion about the atoms from this observation. So they're actually talking about the Rutherford experiment, in which Rutherford directs some alpha particles towards a gold foil. Alpha particles have positive charge. Most of the alpha particles will go straight passing through the gold foil. That means most of the atom is empty. Now, few of the alpha particles will deflect through small angles because they are repelled by nucleus which contain most of the mass of atom. So there are alpha particles which are positive, nucleus is also positive, so they will repel each other and they will deflect through small angle. A very few number of alpha particles will be totally scattered back after collision from the nucleus. If their number is less, that means that the nucleus is very small. So, so answer to the question is most of the atom is empty. That's why alpha particles went straight. Second part says some of alpha particles are deflected through angles of 90-degree and few are deflected through angle of 180-degree. State and explain two conclusions about the nucleus of an atom from this observation. So I have already told you that nucleus is positive because alpha particles are repelled and deflected by a positive charge. And other conclusion is that nucleus is very small because a very few amount of alpha particles was scattered back and deflected back from the nucleus. Now the B part says a source contain a radioactive isotope of strontium. The isotope decay by emission of beta particles. Half-life of isotope is 29 years. State the change in nucleus which occurs when beta particle is emitted. So a heavy or unstable nucleus emits three type of particles: alpha particles when a proton number is greater than 82, and alpha particle is basically helium particle. And it also emit beta particles. Beta particles are of two types: beta negative, which is an electron which have negative charge, and in beta negative decay neutron is converted into proton, and in beta positive decay a positron is emitted which is much like electron but having a positive charge, and a proton is converted into a neutron in beta positive decay. And in gamma decay it's neutral, so there is no such change in an atom. So our answer is if beta particle is emitting, that means it's a beta negative particle or an electron. So a neutron is converted into proton. Second part says the initial mass of isotope of strontium is 25 microgram. Calculate the mass of strontium isotope that decay in 87 years. So first thing is how many half-lives are there in 87 years? So you know that half-life of strontium is 29 years. So 87 divided by 29 is 3. That means in 87 years we have 3 half-lives. So after first half-life, half of 25 microgram would be left, which is 12.5 microgram. After second half-life, 6.25 micrograms would be left. And after third half-life, 3.125 micrograms would be left. So the answer is 3.125. Question number 10 says figure 10.1 represents different positions of moon around the earth from A to H, and this is light of sun which is coming from the right, and these are different phases of moon around the earth. State the position of moon where the observer on the earth sees there is a quarter moon and there is a full moon. Here we have all the phases of moon and the sunlight is coming from the right side, and you see a full moon over this position and you see quarter moon over the top and the bottom. So the answer is you see a quarter moon at position A and E and you see a full moon at position G. So I am writing the answer A and E for quarter and G for full. Second question says state the approximate time for the moon to orbit the earth. Moon takes 28 days to complete a orbit around an earth. B part says the average distance of Earth from Sun is 1.5 into 10 raised to power 8 kilometer. Calculate the average orbital speed of Earth in kilometer per hour. So orbital speed have the formula 2 pi r over t. R is the radius of the orbit and t is the time taken for the orbit. So you're going to take radius in kilometers and time in hours. So it would be 2 times pi times 1.5 into 10 raised to power 8, and the Earth take 365 days for a complete orbit around the Sun. To convert it into hours, you're going to multiply it by 24. So the final answer would be 110,000 kilometers per hour. Second part says the speed of light in vacuum is 3 into 10 raised to power 8. Calculate the time taken for light from the sun to reach the earth. To get the time, the formula is distance over speed. So the distance is already given by the question in the first part, which was 1.5 into 10 raised to power 11, and you're going to divide it by 3 into 10 raised to power 8, so the time is 500 seconds. 11th part says state the condition required for a protostar to become a stable star. Let's suppose it's a protostar and it has a gravitational attractions which are towards the center of the protostar. And there is a fusion reaction occurring in a protostar in which hydrogens are combining to make helium along with a large amount of energy. So energy causes the temperature of the protostar to increase, causing an outward force on the protostar. When this inward force and outward forces are balanced, the protostar is balanced. So the answer is when outward forces due to fusion and the temperature increase balances the inward forces of gravitation, the protostar becomes a stable star. B part says define Hubble constant. It is the ratio of speed at which galaxy is moving away to the distance of the galaxy. Second question says the current estimate for Hubble constant is 2.2 into 10 raised to power negative 18 per second. State the equation which gives an estimate for age of universe. So age of universe can be calculated by taking inverse of Hubble constant. So it is 1 over h naught, which is Hubble constant, or you can say it's d over v. Third part says calculate an estimate value for age of universe. So it's inverse of Hubble constant, so it is inverse of 2.2 into 10 raised to power negative 18. So the age of universe is 4.5 into 10 raised to power 17 seconds. Thanks for watching the video. If you liked it, please hit the like button and subscribe my channel.